A very good afternoon, everyone. My name is Aishani Chadha, and today I'll be presenting on a topic that's both mathematically rich and incredibly practical: events and probabilities. So let's dive in. What is probability? Probability is the chance of an event occurring. When we talk about probability, we're talking about a concept that is omnipresent in our life. From thinking about all the probabilities you have after finishing your work, or the most basic of all probability examples, the mother of probability, gambling. Probability is a part of our day to day activities. We can find it in business, finance, health, etc. Here is the formula for probability: P of E equals number of favorable outcomes divided by the number of possible outcomes. This formula helps us quantify uncertainty in a structured way. Moving forward, in order to learn probability better, we need to understand some key terms. The first one is random experiment. A random experiment is an experiment for which the set of possible outcomes is known. For example, tossing a coin, rolling a die, and drawing a card from a deck. These are all examples of random experiments. Trial. The numerous attempts in the process of an experiment are called trials. In other words, any particular performance of a random experiment is called a trial. For example, tossing a coin is a trial, or perhaps rolling a die is a trial. Event. A trial with a clearly defined outcome is an event. For example, getting a tail when tossing a coin is termed as an event. Random event. An event that cannot be easily predicted is a random event. For example, formation of a rainbow during the rain is a random event. Outcome. This is the result of a trial. In the process of a sports person hitting a ball towards the goalpost, there are two clear outcomes. He may either hit the goal or he missed the goal. Possible outcome. The list of all the outcomes in an experiment can be referred to as possible outcomes. For example, if you're tossing a coin, the possible outcomes here can either getting a heads or getting a tail. Equally likely outcomes. An experiment in which each of the outcomes have an equal probability are known as equally likely outcomes. For example, you're rolling a six-faced die. While rolling a six-faced die, the probability of getting any number is equal. So the probability of getting any number is 1 by 6. Last but not the least, sample space. This is a set of outcomes of all the trials in an experiment. For example, you're rolling a die. The possible outcomes you could get are 1, 2, 3, 4, 5 and 6. These outcomes make up the sample space. Let's move forward to probability relationships. There are 4 kinds of events which fall under the topic probability relationships. We're going to go through each one of them one by one. So the first one is complement event. When we talk about complement event, it means that all the outcomes that are not in event A. Its formula can be read as P of A naught equals 1 minus P of A. When we talk about union of events, it means that either A happens or B happens or both happen. This is its formula. It is also known as the inclusion and exclusion formula, and it can be read as P of A union B equals P of A plus P of B minus P of A intersection B. Intersection of events. This means when both event A and event B happen at the same time. The formula for it can be read below. This is A intersection B equals A or B. Last but not the least is mutually exclusive events. This means when A and B cannot have same outcomes. P of A intersection B equals 0. Now, let's understand these better with the help of an example. As you can see, we have two events defined here. Event A is that the card is a jack. So the number of outcomes in event A can be 4 since there are only 4 jacks in a deck of cards. Event B is that the card is a heart. So number of outcomes in B are 13 since there are 13 hearts in one deck of cards. The total sample size obviously has to be 52 because there are 52 cards in a deck of cards. Now, firstly, we'll talk about the complement event. So complement event is denoted by A naught, which means that the card is not a jack. Anything that is not A is a complement event. So when I use the formula which we discussed before, this is the answer I get. What does this answer mean? This answer means that there's a 12 out of 13 chance of us getting a card that is not a jack. The second one would be union event. What does union event mean? Union of events means that you either get an A or you get a B or you get both of them. In this, we use the inclusion-exclusion formula. As listed before and here as well, we put in all the values and we compute. This is the answer we get after computing according to the formula we've used. This is intersection. Intersection means when both A and B happen at the same time. Think about it. Which cards in a deck of cards are both jacks and hearts? Only the jack of hearts. So the probability of getting a jack of hearts is 1 divided by 52 because there's only a single jack of hearts card in the entire deck. Fourth would be mutually exclusive events. So this was not covered in the previous example. So I will be providing an extra example to explain this. In this, what does it mean? It means that two events are mutually exclusive if they cannot happen together. Now we're talking about event C and event D, which are given as event C is that the card is a king, so we have 4 kings in a deck. Event D is that the card is a queen, so we have 4 queens in the deck. A single card cannot be both a king and a queen. So P of C intersection D equals 0. Moving forward to conditional probability. This is a very important topic when it comes to events and probabilities. Let's talk about it. When we talk about conditional probability, it refers to the likelihood of an event occurring given that another event has already occurred. It's written as P of A given B, which means that the probability of event A occurring given that event B has already occurred. Let's explain this topic using a few examples because the more practical we get, the easier it becomes for us to understand concepts. For example, in a card game, a player needs to draw 2 cards of the same suit in order to win. Of the 52 cards, there are 13 cards in each suit. Suppose first the player draws a heart. Now the player wishes to draw a second heart. Since one heart has already been chosen, there are now 12 hearts remaining in a deck of 51 cards. So the conditional probability is P of drawing a second heart given that first card was a heart and it has already been drawn equals 12 divided by 51. What does this mean? It means that if drawing a second heart is our event A, this is given, and if first card was a heart is event B, which has already occurred. The probability of getting a second card as a heart would be 12 divided by 51. Let's explain it better with another example. Suppose an individual applying to college determines that he has an 80% chance of being accepted and he knows that dormitory housing will only be provided for 60% of all the accepted students. So the chance of being accepted and receiving dormitory housing is given here. I'm assuming you guys understood this. Okay, so now since we've talked about probability, its concepts, the relationships and probability in detail, using examples, applications, and everything. Now we need to understand how we apply probability in real world scenarios. So, probability is more than just a mathematical concept. It's a powerful tool used to make sense of uncertainty in the real world. From predicting the weather to making crucial business decisions, probability theory has a broad range of applications that help guide decisions under uncertainty. Here are a few examples of probability in real world scenarios. I'll explain them to you one by one. When we talk about insurance and risk management, where does probability lie? Insurance companies use the law of large numbers to assess risk. When we talk about finance and investment strategies, here is where Monte Carlo simulations fall in place. They help model investment outcomes, healthcare and medical decision making. Probability is a very important thing when it comes to healthcare because all the diagnostic tests rely on probability to assess accuracy. The last but not the least, predicting human behavior. Behavioral economics helps predict how people make decisions under uncertainty. Now, what does this teach us? These examples show how probability helps us make smarter and data-driven choices. It is what drives the world. It is which is omnipresent, which happens day to day in every office, in every department, everywhere. It is what defines our life choices. Everything is about weighing probabilities. All the information I've shared today is backed by reliable sources like QMath, Khan Academy, Math is Fun, Yale University, and LIS Academy. Thank you so much for your time and attention. I hope this presentation helped you see how probability isn't just about numbers. It's a powerful tool for understanding the world around us. I'm happy and I'm pleased to be presenting this topic, and I'm happy that I got the opportunity to share my knowledge with you.